All right, let's jump into an example. I'm giving you a quadratic function here, and you need to really pay attention at the beginning of the problem. When you are given the definition of a function, that is the rule that you will follow for the entire rest of that problem. So I've said that you're going to let f of x represent 1 minus x squared, which means whatever you plug into function f, you will always square it and then subtract from 1. That is the rule. It doesn't matter what you're working with. So just to emphasize that, part A asked us to find f of 1. And our rule says if we want to find f of 1, we need to take the 1, square it, and subtract it from 1. So we're basically copying what's up above, and where we see an x in that formula, we're replacing it with our input. Order of operations is really important here. This doesn't say square negative 1. This says square 1 and then subtract. So it really is just 1 minus 1, which is 0, and that's a totally acceptable value for a function. What that means is that my y value equals 0, and if my y value equals 0 when my x value is 1, that means I have an x-intercept or a 0. My function has a 0 at x equals 1. The next part is asking us to find an average rate of change, and we just looked in great detail at what that means graphically. This one is just asking us to use a formula. So remember, whenever you see AROC, that is slope, which means we need to find the y values at 0 and 3 and then subtract them. And then we need to divide that by the difference between our x values. So we have a formula. The formula will tell you you should find f of 3 minus f of 1 and divide by 3 minus 1. So our side work for this will just be what is f of 3 and what is f of 1. So over here to the side, I'm going to say f of 3. Well, my function says that I should get 1 minus 3 squared. 3 squared is 9, and 1 minus 9 is negative 8. F of 0, I should get 1 minus 0 squared. 0 squared is still 0, so all I'm left with is 1. So f of 3 is negative 8, f of 1 is 1, and then we're dividing that by 3 minus 1. Notice, be careful with that sign right in the middle. I think people will be pretty good with this, but that is somewhere that people will make mistakes. So I'm seeing a negative 9 over 2. So that's the calculation, and that's fantastic. Reduce the fraction if you can. Again, what that's telling you is the slope of a secant line. So if we wanted to check this out, and absolutely head to Desmos or wherever if you want to check your graphing, but this is a parabola flipped upside down and shifted up 1. So that's what it looks like. And this is saying if we go from 1, which we've already decided is 0, and this won't fit on my graph, but somewhere way out here to 3, negative 8, and we make a line through those 2 points, the slope of that line will be negative 9 halves or negative 4.5. All right, the next two, which apparently are both part C's, are meant to be a pair. You're trying to compare there, and this again is just getting really good with your function notation. So we want f of x plus 1, and then f of the quantity x plus 1. So the first one, we're only plugging in x. We're adding 1 to our output. The second one, we're plugging in x plus 1. So if we plug in x to our function, it will give us back 1 minus x squared. That's how it works. And then this says add 1 to your output. The parentheses don't end up mattering here, but if in doubt, you can always put parentheses around the output that you get from your function to make sure you apply things correctly. Since those ones are both positive, I'm just getting 2 minus x squared from this. Compare and contrast with f of x plus 1, that actually says go to your function and plug in an x plus 1. My function will take whatever I give it and give me back 1 minus my input squared. And this time my input is just an x plus 1 instead of an x. So adding 1 to your input versus adding 1 to your output, this is extremely important when we're doing difference quotients. I would say that's number one mistake, is confusing those two things. And here you should do a little bit of simplification work. And this is actually another really good place to make a point. We have two operations to worry about. We're subtracting and we're squaring. The exponent should happen first. What I'm worried about here is that when you square that, you have to subtract everything and people will forget. So x plus 1 squared is the same as x plus 1 times x plus 1, which will give us x squared plus 2x's plus 1. And then the really key thing there is the distribute. So I'm going to get 1 minus x squared minus 2x minus 1. Again, with difference quotients, which is where we're headed, the number one mistake, the number 1 and number 2 mistake, I guess, are this just notation confusion. But even more common is this one right here, not distributing that negative sign through, and then things don't work out correctly. So notice this time I have a 1 minus 1. So those two will actually zero each other out. And all I'm left with is negative x squared minus 2x. So if you're doing these problems and you're seeing those signs swap, just make sure you go back and check that you didn't forget to include some parentheses somewhere. Okay, last but not least, in fact, most important, is the difference quotient. So this is our big thing for calculus. We're going to use this difference quotient to help us find rates of change. And in particular, it's going to help us find instantaneous rates of change. So it should look maybe reminiscent to our average rate of change formula already. Instead of f of b minus f of a, I have f of x plus h minus f of x, but it's very similar. So we're going to build a fraction, and in the top of that fraction, we need f of x plus h minus f of x. So just kind of as some side work over here, f of x plus h is 1 minus x plus h squared. Again, very important that you plug that h in with your input instead of just tacking it on the end. And we can simplify that here, or we can simplify it within the fraction. It doesn't matter, but I just wanted to point that out. And f of x, that's really just what we started with, and f of x is a 1 minus x squared. So as I'm building this fraction, I need a 1 minus x plus h squared, and then I need to subtract off f of x, which is 1 minus x squared. But there's yet another spot where you can forget parentheses. If you don't include those, you'll end up subtracting the 1, but not subtracting the minus x squared. So you'll have a mistake, and that'll make things not work out. So be really, really careful. You'll get it with some practice if you don't already have this, but just be very careful with parentheses. Okay, so let's go ahead and multiply some of this out. The x plus h squared means x plus h times x plus h. No distributing exponents, it doesn't work. So we'll be subtracting an x squared, 2 hx's, and an h squared. So be very careful with those. Notice the 2hx is from the x times h plus another x times h. That's why there's 2 of them. And it doesn't matter if you write hx or xh, but do recognize that they're the same. I've kind of forced myself to get in the habit of alphabetizing when I have more than one variable, just so that I don't accidentally confuse myself if I have a 2hx and an xh. Those are like terms, but sometimes people miss it if they write them in the opposite order. Okay, and then I'm going to have a minus 1, and it becomes a plus x squared. So that right there is really key. That's like the most common mistake, is messing up that negative. And these look a little ugly, but it should start to clean up really quickly. I have another negative to distribute. Again, most common mistake is just to mess up those negatives. So it's becoming a minus x squared, a minus 2hx, and a minus h squared. And then we have this minus 1 plus x squared. If you spotted in the last step that the 1s are going to go away, it's totally fine to have gotten rid of them already. I didn't catch that until after I wrote it down. So I'm seeing a 1 minus 1. That's going to zero out. I'm also seeing a negative x squared plus an x squared. That adds up to 0, so all gone. So really all I'm left with is a negative 2hx minus h squared divided by h. And I'm almost done. Always the goal with difference quotients, and you'll understand why very soon, is to cancel that h out of the bottom. I don't care if there's other stuff in the bottom, just not that lonely h. And I can actually do that now. And that's why all that simplification was important. Notice that the top has h's in both terms. So this right here splits it into 2 terms. We have a negative 2hx and a negative h squared. We can factor an h out of that, and it'll leave us with just a negative 2x and a negative h. And then I can cancel that h out, and that's when I'm done. So always be looking to cancel that h out. We'll clarify why shortly, but just know that's your goal, is to get that lone h canceled out of the denominator. All right, thanks for watching.